Good. Okay, then we're moving on to our next presenter, which is Professor Grazyna Pazikowska-Sapota. I hope that was not too bad. I tried to practice the name, from the Maritime Institute in Poland. Thank you very much. Sorry. At least you knew her name.
My name is Grazyna Pazikowska-Sapota.
Sorry.
Ladies and gentlemen, I am very pleased to welcome you on behalf of myself and Maciej Matczak, the director of Maritime Institute, Gdynia Maritime University, who unfortunately could not be present today. I hope that the thematic scope proposed by us in this conference will meet your interest and expectations. Full title of our project sounds liquefied biogas as a driving force for the development and use of green energy technology. And today I would like to tell you, among others, why we took up this topic regarding green energy. The European Union is committed to full decarbonization as a basis for achieving climate neutrality. However, this requires a complete overhaul of the energy system and its infrastructure by 2050. This goal underpins the European Green Deal, which includes a wide range of plans to intensify policies on climate change mitigation. The transition to a climate neutral society will require significant investments in energy efficiency, renewable energy, new low carbon technologies, and grid infrastructure. Both societies and sectors of the economy will play a key role in this action, from energy to industry, transport, housing, services, agriculture, and forestry, which will have to reduce greenhouse gas emissions, example by ending the use of fossil fuels. Combined with the existing gas infrastructure, renewable and low carbon gases can help to achieve the transition to a net zero greenhouse gas emissions green energy system with the lowest social cost. However, it is multi-faceted transformation and consists of many interrelated market, technological and legal changes. What are greenhouse gases? These are gases that transmit most of the solar radiation reaching the Earth, so-called short-wave radiation, while absorbing the infrared radiation, so-called long-wave radiation, reflected by the Earth surface. By absorbing infrared radiation, greenhouse gases contribute to the greenhouse effect. The Kyoto Protocol includes and defines 6 greenhouse gases. These are carbon dioxide, methane, nitrous oxide, fluorohydrocarbons, perfluorohydrocarbons, and sulfur hexafluoride. Changes in the concentration of greenhouse gases in the atmosphere can be caused by both natural and factors and human activity. The figure shows the effects of anthropogenic CO2 emissions and the transient temperature response to cumulative emissions of CO2 and other greenhouse gases from the perspective of carbon cycle processes. While this scheme is based on CO2, the dominant greenhouse gas, some of the same processes also affect methane and nitrous oxide fluxes, and the strength of positive feedback from land and ocean systems. Feedbacks between carbon and climate can amplify or dampen climate change by altering the rate at which CO2 builds up in the atmosphere. The next figure shows the global near-surface air temperature time series, GSAT, for individual forcing agents. As we can see, the global mean annual surface air temperature has increased over the last 200 years. And each of the last 3 decades has been warmer than the previous one. The last decade is the warmest decade in the instrumental record dating back to 1750. Detailed analysis show that for most of the historical period, the total estimation of the long-term GSAT trend is closely related to the contribution of CO2. The Intergovernmental Panel on Climate Change attributes global warming mainly to CO2 emissions related to fossil fuels. The contribution of different greenhouse gases to global warming is not the same. The figure shows the modeled warming caused by the emissions of each gas or group of gases, calculated using a climate model of reduced complexity that has been calibrated to fit several aspects of the overall assessment. The emissions weighted by global warming potential with a lifetime of 100 years confirm the increase in most greenhouse gas emissions, with carbon dioxide being the dominant and methane the second most important contributor to warming. The next figure highlights the total anthropogenic greenhouse gas emissions in the period 1990 to 2019, where CO2 from fossil fuel combustion is the largest percentage. The forecast of changes in energy sources until 2050 in the EU area assumes a decrease in the share of petroleum products, a significant decrease in the share of solid fossil fuels, and an increase in the share of renewable energy sources in the structure of the energy mix. The forecast also predicts that the LNG use will remain relatively stable over time, with a slightly declining trend. Renewable energy sources seem to be an opportunity, especially the increase in the share of biomass and waste in obtaining energy. The question is, how can we more contribute to mitigating climate change? In 2013, the European Commission proposed guidelines for the preparation of a climate change adaptation strategy. Also, the Paris Agreement adopts a bottom-up approach in which countries determine their contribution to reach the PA's long-term goal. However, individual countries have developed their strategies very differently in terms of approach or level of detail. Some countries have adopted a very synthetic approach, and others have developed solutions in great detail. In any case, general climate change mitigation and development pathways in the near to mid-term should include measures to enable shift in development pathway, strengthening governance and institutional capacity, facilitating behavior change, aligning technology and innovation systems, and aligning finance and investment institutions. As the figure illustrates, public policies are required to foster both accelerating mitigation and shifting development pathways. Improved governance and enhanced institutional capacity facilitate the adoption of policies that accelerate mitigation and shift development pathways with the potential to achieve multiple mitigation and development objectives. Finance, of course, is required both to accelerate mitigation and to shift development pathways. Accelerated mitigation encompasses both changes in consumption patterns and behavior change, as well as rapid deployment of new technologies. And our liquid energy project is more or less part of this step towards climate change mitigation. Because the development or application of new solutions enabling a wider use of bio-LNG as an energy source is a specific technical and business problem dealt with by a liquid energy project. The project creates a framework for broader and more universal future use of bio-LNG in a micro and nano form as an alternative fuel, for example, in the decentralized energy supply system. Our project is implemented under the Interreg South-Baltic program by one partner from Lithuania, 3 partners from Germany, and 4 partners from Poland. The main goals of Liquid Energy Project were a presentation of new and innovative technical solutions related to bio-LNG through the implementation of pilot investments, opening a new market for users of bio-LNG as a source of energy on a micro and nano scale, and also analytical activities. The second goal was promoting cross-border cooperation for the development of environmentally friendly technologies, services, products, and standards through the B2B, business-to-business online platform. Detailed information about the implementation of the project's investments, as well as the achieved results, will be provided by my colleagues. partners of the project in subsequent presentations. Thank you very much for your attention. Thank you.